Okay, so today we are going to work with this, with y equals minus 2 sine of 3x minus 1. And what we are going to do today is to explain the function, explain the function and its aspects, and how these aspects transform the graph. If yeah, so we're going to start with, we have to know what kind of graph of function we're working with. It is a y equals minus 2 sine of 3x minus 1, which is, well, it is a sine function. It is y equals sine of x. So if you're familiar with y equals sine of x, you know that it just goes like this. It starts in the center and it goes up and down and up and down, and on the other side too. Okay, that's the only thing. That's a normal sine function without any transformation, without anything changing. And how do we know what changes? Well, the function tells us what changes. It is in this way: y equals a sine of bx minus c plus d. So now I'm going to explain how a, how b, how c, and d, how these four letters, these four values, transform this sine function into something that looks a bit like this, but not quite. So first, let's look at a. What does a do and what it is? A is amplitude. What is amplitude? Well, from the midline, which we're going to deal with later, from the midline to the top or the maximum, and also from the midline to the minimum or the bottom, if you want to call it that. It is the value from the midline to these 2 points, the maximum and the minimum. That is what amplitude is. To get amplitude, you will have amplitude equals absolute value of a, and that's it. That's pretty much it when it comes to amplitude. It's really not a hard one. Of course, it cannot be negative because it is a measure. So yeah, that's the thing. Now, sorry, I forgot to mention what a does. So here we have minus 2 sine of 3x minus 1. So I'm going to take the sine function, and let's just turn it into minus sine of x. This is, well, this might look like just a small change, but it pretty much inverts the whole graph. So instead from going up, instead of going up, it will go down from the origin. So it goes down and up, down and up, and the same thing on the other side. So this is one transformation. Also, I'm going to add this because, yeah, this is one of the transformations. Instead of going up, it goes down, the wave. So yeah, that's the change that a does. Now let's look at the next thing, which is b. B. B is okay. B is this part here. What B does, B is the frequency. B is the frequency, and pretty much it determines if the period increases or decreases. So the bigger it is, the skinnier, if you can call it like that, the graph gets. So let's do minus sine of, this is x, right? We're going to say that we're not going to work with minus sign. Okay, we're going to write sine of 2x, and we're going to draw it below above. Hope it does not become that messy. And well, here's the graph, and it will go like ooh, 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 ooh. And the other side too. And as you can see, well, actually no, you cannot see, sorry about that. Here is, compare the blue one, which is sine of x, and the green one, which is sine of 2x, which is more frequent and the waves appear skinnier. And if this were to become a decimal, it will only, if it became a decimal, it will do the opposite. It will extend. You make them the opposite of skinny. It will enlarge the waves. So yeah, that's the change that B does, which is frequency. And yeah, that's frequency. Okay. Now we're going to see what C does. Okay, C. No, we're going to look at C and D. C and D, the only thing that do is either, in the case of C, it moves the graph to the right or the left because it is on the x-axis. So let's see. Okay, we're going to use sine of B, yeah, sine of x minus 1, and this will be like this. You can see, yeah, you can see, wow. Okay, it is bx minus c, so because it is minus, no, this means that it goes above. Okay, so instead of starting here, that, let's say that this is 1, so it will go like, so I'm going to write a few numbers just to, this is 1, so yeah, the graph move to the right because of this. And if it were x plus 1, it would move to the left, to the other side. And now D, well, I'm going to write it down because I'm already writing down everything. So x plus 1, and instead of starting here, start like here, and whoa. And yeah, that was C does. And D, which is the one that, is it working right? Is the camera working? I don't know. Okay, what D does, D does, what D does is, it is just moves the graph up or down, it moves the midline. So again, here it is, here are the graphs, and you cannot see one, but I'm going to show it to you eventually. Sine of x minus 1 and sine of x plus 1. Okay, sine of x minus 1, this means that it will go 1 below and the other one will go 1 above. And I'm going to do them in different colors so it looks easier. So it is easier to see. And okay, okay, I know this may okay, I know this is a horrible drawing actually, but yeah, the minus 1 means that all the graph will go 1 below, and the plus 1 makes the graph go 1 above. Okay, and yeah, those, wait, I'm going to accommodate these. Okay, those are the transformations that can happen. Now we're going to see another thing. I'm going to erase all of this. Okay. Oh, a small mistake that I did right now. Well, not mistake, but I should have done later is not tell you yet the formula of amplitude. That is something that we are going to see now. The formulas of many aspects of the graph. And okay. We're going to okay. First let's draw a graph, right? So we're going to draw the normal sine, and we're going to draw here the one that we're going to do right now, which is the minus 2 sine of 3x minus 1. So the sine will just be like this. Yeah, the boring same sine of always. I don't know. And well, we can get an image of this. Does not go here. Okay. Yeah. We have the minus 2, so we know that it is going downwards, and the amplitude is bigger, so it's going to be the range is going to be higher if you are into that, of course. And yeah, so it's going to be higher. The range is going to be higher, and it's going to start below. Okay, the normal sine is just one amplitude, and this one will have an amplitude of 2. Okay, now the 3, which is the frequency, will make it more skinny, 3 times more skinny. It will be like the period will be a third of the normal sine graph. Alright, so that's another thing that we know from the graph. And the last thing is the minus 1, because we do not have a c, so there's no change in the x-axis, but there it is in the y-axis, and that's the change of d, which is minus 1, and that means that, well, the whole graph will be 1 block unit below. And yeah, so with that out of the way, we're going to just graph this again in the ugliest way possible. And yeah, so it goes like ooh, 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 ooh. Yeah, this is horrible. Okay, so that will be the graph. But I have mentioned a lot of things in the graph and the sine function that I have not explained yet. So let's go over those. Not real quickly. We have a lot of time. Yeah, we've been recording 30 minutes. Okay, that's fine. That's fine. It's not half an hour like creative contribution number 7. Oh boy. So the amplitude. The amplitude. Okay. I'm going to write it down. Amplitude. Which was A is like that. Amplitude, which is A, it is the way to get it is just as I said at the start. Well, I should have contained that for right now, but yeah, amplitude equals absolute value of A. A is -2, so it is absolute value of -2, and we get 2. And well, because this one is the normal sine function, the usual one, the one that has no modifications. Well, it has an amplitude of 1, right? And this one has an amplitude of 2, which can be seen because this one is the range is bigger. I believe that is a way to understand it. Okay, so that's the amplitude. The amplitude will be this and this, from the midline to the maximum and from the midline to the minimum, not together. Now let's look at the period. Okay, period. Oopsie, period P. It is equals to 2 pi over absolute value of B. So the period of a normal sine function is 2 pi. So this is 0, this is pi, and this is 2 pi. Okay, but because this is 3 times skinnier, it does that lapse in a shorter distance. So this gives us 2 pi over absolute value of, it is 3, yeah, which is 2 pi over 3. So let's see. Okay, this is 0, this is 2 pi over 3, this is pi over 3. Okay, I'm analyzing this. Okay, this is 0, this is pi over 3, and this is 2 pi over 3. And as the period is like the lapse, the circuit, it is one lapse, one circuit in the frequency before it starts repeating infinitely. And here it has, in the normal one, it has a frequency of 2 pi, because yeah, we have to compare both. And now midline, which I have been mentioning a lot. the midline equals d, because it is just the change in changing the y-axis. If it goes, if the graph goes, if the whole graph goes above, if it goes up or below. So it is d, which is -1. Therefore the midline is y equals -1, because we gotta write them in this way, right? And also I gotta write a equals 2 and p equals 2 pi over 3. Yeah, you can see everything. That's great. For a second thought that you could not, but yeah. Now my head horse teacher. Okay, phase shift and vertical shift. The phase shift is change in C, changes. Wait. Okay, I'm back. Sorry about that. Okay, the phase shift is. Wait, we already kind of talk about it. So C is to the phase shift as D is to the vertical shift. So the phase shift is the change from right to left on the x-axis if everything moves, and the vertical shift is the up and down. Yeah, the vertical shift is if it moves up or down or does not move at all. But yeah, and it has the same value at the midline. So from this, the phase shift equals C. Oh no, I want yeah, why not? C over V, which equals 0 over 3, which equals 0. So the phase shift equals 0, and the vertical shift equals D, which equals -1. And let's write these two down. Phase shift equals 0 and vertical shift equals -1. And okay, now I realize that I don't think I explained the relationship between the common sine function and the midline, the phase shift, and the vertical shift. But it is pretty easy, believe me. The sine shift, sine shift. I'm making up words. The normal sine function has no c nor d, so both values are 0. They don't move up or below. So yeah, phase shift is 0, vertical shift is 0, as you can see here. It is on the center of everything. And the midline will be also 0, because it did not move. It is just there in the infinity of the x-axis. And yeah, actually I'm going to see if what I did was correct. Okay, I don't know if I explained it. I mean, I just compare the two graphs of the normal sine and our equation, which is it is this, and we're going to graph it better because this is ugly. I'm not going to write everything again. I mean, I'm sure I'm going to remember them, the values. Okay. No, I did not have to erase it. Okay. 3 pi over 2 and 2 pi and minus pi over 2 minus pi minus 3 pi over 2 minus 2 pi. Okay, this is a normal sign. Okay, so it goes up and down, and yeah, that's it. Ooh, y equals sine of x, and that's it. Okay, I forgot something. This is 1, and of course this is minus 1. Alright, yeah, that's the y equals sine of x function. And now let's see to the y equals minus 2 sine of 3x minus 1. Okay. Okay. Okay, the green thing is the midline, which is minus the midline, which is minus 1. Y equals minus 1. It goes 1 below, and it is. I was going to graph it, but first I'm going to add the values. 2 pi over 3 pi over 3. I know it's not the best place to add them. Oh, no. Okay, 1 minus 1, and this is minus 2. 2 and 3, and there's also pi over 3, pi over 6, and pi over 2. Wait, I'm taking this correctly. Okay. Okay. 2 pi over 3, pi over 3, pi over 2. 1/6 plus 1/6 is 1/3. 1/6 plus 1/6 plus 1/6 is 1/2. 1/6 plus 1/6 plus 1/6 plus 1/6 is 2/3. Okay, this is correct. 1, 2, 3, 4. Okay. I'm not. Yeah. Yeah, I mean, it is becoming too crowded. Minus pi over 6 minus pi over 3 minus pi over 2 minus 2 pi over 3. Okay, and now minus, it goes below, it goes below, it is 2, so it's going to be, well, bigger, yeah. And 3x is going to be more skinny. I mean, you can see the difference from both graphs. And yeah, okay, I think we're ready to graph it. The midline is -1. Okay, I was searching for anything that was wrong, but there's nothing. Okay, let's go. Oopsie, this is not supposed to reach this part. Ooh, okay. And this is it. This is the graph. Okay, okay. Yeah, that's the graph. And I think that's how. Yeah, it's going to be 20 minutes, but that's fine. Okay. No, I think I realized what. I thought something was missing. Okay. We're going to add in the graph what we know there is. So, okay, this is the amplitude. 2. Amplitude which equals 2. 2 upwards and 2 downwards. Now the period is this one. Oh God. You cannot see it. Okay, the period is this one, a full lapse, which is p equals 2 pi over 3. Okay, the midline, well, it is this massive thing that goes infinitely, which is the midline is y equals -1, and phase shift, the phase shift, the phase shift equals okay. The phase shift is 0. There was no movement in the x-axis. Yeah, it is 0. And well, I'm not going to write that down. It does not exist. And vertical shift, this one equals -1, and I'm going to write that one here, and yeah, it is right there. And yeah, this is the whole this is the whole graph, finally, with the 5 key points and transformations and the conventions with sine of x. Okay, that's great.